Hello, hello, hello. We should be live, I think. Maybe. Yay. Okay. Looks like we are live. Mm-mm-mm-mm. All right. Welcome back. Welcome back. Um. So, we are basically just gonna pick up where we left off last time. We started looking at the runner's code in a simulator. I think we went through the bug base um, implementation. And oh man, it's gonna be a long night, isn't it? um, yeah, I don't think I have so much introduction introduction introductionary. Is that a word? Introductory. Jesus. Introductionary. Oh my gosh. Introductory. I know words. I promise. Um, introductory words for this. I mean, it's a series. So it's, we just kind of pick up where we left off. And in the last stream, again, we started looking at the runner's code. So far we've covered what's in main, meaning the entry point of the crate basically. Then we went into shrink. We talked about why would you even want to have a procedure to shrink you know a a simulation run. So we did that. Then we started looking at the runner, the simulation runner, and mainly I think the main thing here, well, one of the main components of the runner is the bug base, which is where the bugs are stored. Yeah. So next, I think what at least for this evening, for tonight, I think what I want to look at, I don't think I want to look at the CLI stuff. I mean, I don't know, I feel like that's pretty trivial. We can always ignore it until later. Differential, maybe we'll look at that today. Excuse me. And I'm also thinking maybe we just do IO and watch. Although I feel like we've had a glimpse at watch when we were looking at main. Anyway, so we can do watch, IO, and file, which I want to say probably depends on IO, or maybe not, never mind. Or does IO depend on file? Yeah, okay, depends on file. So watch, file, IO sounds like a good mix for this evening, for tonight. So I think we'll do that. And I think we'll start with, well, okay, so watch, what dependencies does it have? Oh, it has dependency on generation. Okay, then maybe watches won't be, is not a great pick because it has dependencies on a bunch of stuff that we haven't looked at yet. And that are not IO or file, so maybe we hold off on that and let's just focus on IO and file for now, and we'll see where that gets us. All right, let's do it. About to read some code. All right, so so a bunch of stuff for random generation. Wait, is this from the standard library? It feels like it is from the standard library. What about this one? Rain Cha-Cha. Okay, it's a crate. Okay, whatever. It's not internal. So from the limbo call, we have the clock, the instant, the open flag, the platform, the result, and IO. Okay. So IO is a trait. Okay, you open a file. Random, generate random number, generate memory. Oh, get memory IO. All right. No, wrong one. Shoot, I already forgot. Ah, okay, there it is. Similar to IO. Okay, so we have the box here because we don't know the size or whatever object this is at compile time, so we box it and it's a trait, so we need some form of, I think dyne is really to indicate dynamic dispatch, if I remember right. Well, no, I mean it is that. It's just I'm sure there's a more elaborate way to explain that, but I would say that's out of scope from what we're doing. So ref cell, we can ask don't know what to select. I want Gemini Pro. Although DevSecR one, I feel like I haven't used that before. At least not on cursor. Give me a quick refresher on WebCell. I know it's for interior mutability and it's single threaded. What else do I remember? Dynamically check rows, so it's a runtime. No, I think I do want a refresher. Yes, intermutability, I get that. Runtime bubble checking. Single threaded, yes. Cover that. Call methods, you borrow mute. Okay. Try borrow mute. Needless to say, if you care, it depends on the kind of software you're building, but if you're trying to err on the side of safety, you probably want to use the try methods. But then again, depending on what you're building, you may be in a context where you want to bail as quickly as possible when you notice that something is not exactly the way you expect it to be. So you may just want to use these directly. Caching and memorization, mock objects, graph-like structures. Excuse me. Overlapping borrows cause panics. No compile time safety. Often paired with for shared ownership and immutability. I feel like I know why you usually wrap it in an RC, but I think I want to refresh it for that as well. How about so okay, let me see. So it's still single threaded. Now you're wrapping in a reference counter. So I think the difference is that by construction with the RC, you won't be able to acquire a shared reference if there is already a wait, is this true? Yeah. Wait, what? Yeah. Yeah. You won't be able to acquire a. But I feel like that's even checked at compile time, right? That's what the RC really, when it comes down to it, that's what it brings to the table. Watch me be completely wrong. It's nice to get a refresher on these things. Okay. So yeah, still single threaded, like I said. One time borrow checking. Okay, never mind. There's no compile time enforcement. Automatically deallocates when the last RC reference drops. Oh, okay, the typical graph/tree Example. Reference cycles, memory leaks. Okay, yeah, that sounds familiar now. So, okay, so shared ownership through reference counting, hence the RC. So yeah, so multiple parts of your single thread program want to have access to the same object. They want shared ownership, and at the same time, through RefCell, you also want each of those holders to be able to modify the underlying data. Okay. All right. That was a quick refresher. So here we have files. Simulator files. I'm sure we'll get around to this. Wait, should we be looking at simulator file before? Maybe we should. Okay. So the inner file is whatever implements the file trait. Also trying to make this thread safe by using the awk. RefCell. What else? Everything is a RefCell. Okay. Okay, so to inject a fault. Oh, wait a minute. Where is it? Where's fault? Okay, RefCell. Okay. Basically replace the value in yeah. Yes, replace in place. Okay, that's why I was hesitant to say it because it sounds funny. Replace in place the fault flag value. Well, flag. Print stats. It's whatever. Just printing stuff. So now we implement the actual file interface slash straight. Okay, so locking the file. So you has to borrow. If it's true. Wait, so if a fault is injected, then you cannot lock a file, basically. Or you cannot acquire a lock to the particular file. Okay. Just confirming. Okay. Something for unlock. P-read. Of the completion object. Okay. Under which circumstances does this fail? The borrow mute. Well, let me see. Let's think about this. What would it fail? Well, if there was already a wait, but what do you get back? Borrow mute. Like, is it something that you can actually carry around? Well, yeah, you can assign it to something. So yeah, the borrow mode panics because there's already a standing shared borrow. Anyway, what led me here again? I think I was thinking about the fact that this could trigger a panic if we have a standing shared reference. Yeah. The value cannot be borrowed while this borrow is active. Alright. So period calls. Okay. We increment that for statistics, keeping stats. Okay. So you increment this, then you check if there's a fault. So this is the happy path. Otherwise, we have a branch for when there is a fault injection directive. Okay, so P write, process write. Takes a position, a buffer, so a position within the buffer, so basically an offset into the buffer. And then the completion object. Same story, just logging things. There's the unexpected branch. of execution. And then we just write. Oh, forgot. I wanted some music on. Let's go see how that works. Okay, Nicole IO. Choice file, so you have lock, unlock, period, P. What is, that has to be an implementation, right? Are you using? Yeah, let's not get sidetracked. I think it's pretty straightforward what's happening here. You take the inner file that's being wrapped. You have the offset, the buffer to write to the file, and on done you use the completion object. Alright, for a sync. That's very standard, straightforward. Again, we do some sort of metering or counting, whatever you want to call it. And then we sync the underlining file. Okay. So we're back to IO. Just have a feeling that this, well, okay, never mind. And page size, blah blah blah. Okay, so have your seed, your page size. By page size, I think they mean the OS page size, I believe, which is usually 4 kilobytes, I guess. So you have a constructor, text in a seed and a page size. Okay. So many ref cells. Yeah. Okay. So when you say inject fault, it's just literally flipping the byte. Oh, I guess it's either that or you have a no op. Why? That's a static clock, right? I'm not crazy. I mean, it definitely looks like it was by design based on the fact that there is this comment here. Anyway, so we did, so that's the IO, we have the clock, but also the IO implementation. What does it mean to open a file for a simulator IO? So you have the path, the flags. I mean, direct, means just direct IO. Doesn't say it in the documentation here. That's okay. Okay, so we have the inner file. Okay, so this here, you instantiate a simulator file. So there's, okay, so yeah, the simulator keeps tabs on all the things, all the files that it's currently responsible for. I feel like I just experienced a glitch. Reading code late at night is a bit of a challenge sometimes. Yeah, that was a glitch. Lost track of where I was. Okay, so new file. Well, it doesn't have to be new, right? Okay, so we acquire the inner file, and from that, we'll spin up a simulator file, and then push that into our registry of files. Run once. So we borrow, we log the fact that we borrowed. Okay, I guess we just where was I going with that? Another pass through. Oh, I guess proxying, I should say. This is pretty straightforward. Okay, return the next U64. Alright, I think that was it for the IO stuff. That was pretty straightforward. And now we are in file. Just taking a quick break. This stream might be the shortest one we do in a while, cause yeah, my brain is aggressively signaling that it has had enough for today. Let's oh, I think we did this, right? Yeah, we did file and we did IO. At least we just finished it. Straightforward. You have a simulator file which is based on the simulator IO. It's gonna be interesting trying to replicate this in lingua franca. We'll see. What does environment have? Simulation environment. What is the execution? Okay, let's look at simulator environment. Saying simulator options, table, vector of tables, simulation connection. Simulator IO, database. It's probably used for the seed. It's quite possible that this is maybe the first reactor that we write. So I feel like it's like well, it's the incubator for the simulation. Makes sense that it has all these components. Okay, so you can clone an environment without its connections. Okay. Okay, so this is the factory simulation options, the seed, the path. Makes sense. So you generate your seed, or at least you have a constructor or a factory, a generator, whatever you want to call it, for generating random numbers, except they're not totally random. They have a seed to go along with it. Um, create read, right. This probably is just to control the way in which, I guess, the properties or the interaction planes are generated. So this is our parameter setup. Okay. Simulator options. What does it take here concretely? Max connections 1 to do for now. Let's use one connections within implement. Correct transactions processing. Okay, so that's a follow up. Okay. Max tables 128. So this is the maximum amount of tables that the simulation should spawn and create. After that is a bunch of parameters. Page size, randomization. What would be a sane way to do that? Choose a random number between, I don't know, a reasonable range or domain, I guess, of natural numbers, and make that, I don't know, powers of 2. Yeah. So the power of 2 over over a reasonable range of natural numbers. you know, I'm sure there's other stuff that you can think of for how you sample the page sizes from the domain. And also you may have some sort of constraints where based on the output you decide to rerun the sampling to pick a page size. But anyway, I don't know why I'm spending so much time on that. Okay, so for IO, have the simulator IO. Wait, which one is? Yeah, okay, that's the one we just looked at. Alright. What is it? No, environment, sorry. Okay. Okay, so we're acquiring a simulator. If the database exists, we trim it, truncate it, delete it, whatever you want to call it. Do the same thing if there is a wall at the same path. So, okay, and then that gets leveraged in the factory for the database. And obviously connections, you get it from the parameters that were specified in the simulator options. I guess right now it's just one, so okay, so that's the simulator environment. Connection trait, set it connected or not. Simulation connection. Okay. So when you check if it's connected or not, so this is pretty straightforward. Okay, so on disconnect we place, okay, so we do the in place replacement, and as a return value we get the old well, yeah, this returns the old value that was there. Excuse me. If it's already disconnected, it's a no op. In both other cases, it's well, for most people it's a nothing but, well, what am I saying? Yeah, that was weird. I was about to say something and then I realized, wait, this feels like a different context altogether. Oh man, I'm telling you, reading code this late in the day. Wow. Yeah. I envy people who can get 8 hours of sleep and just, you know, or can get less. I would say 4 or 5 hours and just be fine. Because apparently that's not in my wheelhouse. And when it gets to be this time of the day, my brain just, yeah. But it's a good thing we're almost done. Well, I think we probably are going to stop here. Because I think my brain has entered glitch mode when it comes to reading code right now. But I mean, yeah, this is pretty straightforward in terms of the environment stuff set up. Well, okay. Generally speaking, I think the goal this week is to be done with reading the code. Next week we definitely are starting to write some code, which means I need to figure out how to actually get the thing running on my machine locally, which I haven't been able to because of some stupid package thingy. I think we should be able to get through the whole code base by the end of this week. If we don't, well, I'll just do the rest of it on my own without a stream, which probably will go faster because I don't have to talk. And yeah, I think I'm actually eager to start writing some code, or at least attempting to do a port or a translation, whatever you want to call it. Will be my first serious project in lingua franca, so we'll see how that goes. Yeah, anyway, so the plan is to finish reading the code this week. So far I don't think we made great progress today, but that's okay. It is what it is. But tomorrow we definitely, tomorrow is gonna be a long day. Just realized that. So I might not actually stream tomorrow. Ouch. Well, I guess Wednesday then. Maybe we'll have to start early on Wednesday. We definitely need to finish Runner, and I think we definitely need to I want to say generation is probably more important than model. So on Wednesday I think we'll try to finish the Runner and the generation, or at least get halfway through generation on Wednesday. But then again, we'll see how tomorrow goes. But based on what I imagine the day will be like tomorrow, I don't think there'll be a stream tomorrow. So tomorrow is gonna be a pretty long day, I think. Yeah. Alright, so what do we want to do for the rest of the stream? we don't actually have to do anything. We can just go and go to sleep. I mean, that's probably the smart choice, but what's the fun in that? Freedom on a mode. Oh, what's this? Oh yeah, Kafka. I was gonna say Kafka operator. Now I mean Kubernetes operator. I want to write one. That's another thing that I would like to do relatively soon. Hmm. All right, I think I need to log off because weirdly my brain's very aggressively telling me to go to sleep, to go to bed. So I think I'm just gonna do that. So yeah, I'll see you guys tomorrow.